Yes. So now that we have coded and done our transformer block, we are almost there. So we've done this transformer block. We now want to put it into the GPT model. GPT model. In code, we started with our dummy GPT and we built parts as we went. The layer normalization, the feed forward network, and all of that. So we now want to put those transformer blocks that we built, the layer normalization, and wrap them in the GPT model. We did say the GPT model is much, much bigger than what we have here on screen, which is our transformer block. So let me actually see if I can do this. So without having to write everything, bear with me. Hopefully this works as well as I'm hoping it will. Okay. And then let's select the one to move it, right? So let's move this down a bit. So these are embeddings that we have in our so let's not call them embeddings right now. Let's actually get rid of this thing. Let's get rid of this thing. Put it down there because I want to add something here. We want to explain how we are going to connect this to the transformer block. So you remember that we have our text. Our text is going to be, let's change that to a pen. So our text is going to be every effort, every effort moves you. That's the text that we have. So what we are going to do is we are going to tokenize text, right? We're going to tokenize it first. And after tokenizing it, we are going to create what are called what? Token embeddings. So we're going to get into this token embeddings layer. And after that, we are going to create positional embeddings. Positional embeddings. Going to add our positional embeddings there. And then we are going to have dropout. We're going to have dropout. And this worked perfectly. Good calculation. And then we enter into our transformer block. We enter into our transformer block where we'll have our layer normalization, our multi-head attention, our dropout again, our layer normalization, our feed forward that looks like that on the right side, and our dropout. And after this dropout, what we're going to have is our final layer normalization. We're going to normalize it again. And then after normalizing again, we're going to have a linear output layer. Linear output layer right there. And this should hopefully, let's get rid of that part where we can, I think that we can at least erase this. Just use the eraser. We can just smudge it like this so that it doesn't confuse us. So when an input goes in, because now with that input, every effort moves you, it's going to output here. It's going to output, let's say, this array. Let's just give this as an example. We are going to have an output that's going to be maybe 0.0055 all the way up to minus 0.4747. And then we will have another row which is 0.2663. Then it will be minus 0.4224. And then we'll have 1.1146 up to 0.0276. And then the last one that we'll have is minus 0.8239 and all the way up to minus 0.3993. So that is what we have, right? It is a 4 by 50,257 dimensional vector. Interesting. Why 50,257 and not 768? It's because this this last linear layer, it embeds what comes out into a 50,257 dimensional space, because it is the size of our vocabulary. Because what would then happen is we are hoping that this last term, the goal is for there to be embedding, for the embeddings to be converted back to text. So we hope that this last part here, if we go into our vocabulary and do a lookup, we hope that this represents the word forward. That is what we are hoping for. So now let's highlight what the GPT model. So the GPT model actually starts, it is everything right here. So this whole thing is the GPT model. So let's scroll down all the way down. All of this is a GPT model, all of this, including this transformer block that we have, the transformer block that we have going all the way down, all the way down. If you're writing this on paper, you actually see this better on paper because you don't have to scroll all the way down. This is our GPT model all the way down to here. No, not to there. Tokenization is not part of the GPT model. Calculating the embeddings, yes, it is. So that is what our GPT model is. So that's what we want to now look at the code. How do we add these positional embeddings, token embeddings? Transformer block, we have already done the transformer block. That's what we did in the previous video. So we have that ready, including its layer normalizations. And then we just add these final layers as well. Another change that is going to happen is for us to really be consistent with the model, the GPT model, GPT-2 model, is this transformer block, it is repeated 12 times. It is repeated 12 times. So it's just copy, paste, copy, paste, copy, paste 12 times, pretty much. And then data follows through those 12 transformer blocks. Like I said, some of them we have 96 repetitions of this transformer block, others 30, 32, and all of that. But yeah, that's just it. So let's see in code how this looks like. It actually, we've done the heavy lifting already. So this is it right here. This is the GPT model. We have our token embeddings. That's going to be our embedding, our position embeddings, and then our dropout when we drop out the embeddings. Because we say we first do, we token after tokenizing the text, we embed the text tokens, we add positional embeddings, and then we do dropout first. So this is just dropout that is dedicated to the embeddings. Then our transformer blocks is just going to be sequential, which means we are putting them in sequence, right? We want to repeat them as how many layers there are going to be. We are going to use maybe 12 layers. So we're just saying this transformer block needs to be repeated maybe 12 times. That's essentially, this is now the transformer blocks. They are put there. And then we have our final normalization layer here, and we have our output head. Our output head, like we said, we briefly mentioned it, but we have seen what it looks like now. Our output head will now be this linear here, and it will take in the embeddings size 768, and its output will be the vocabulary size, so that we can do a lookup. We'll do a lookup. We'll say, okay, this is now what the result is. Let's go to our vocabulary. What is the token ID? What is the token ID for this one here? Okay, or what is the actual word? What is the token according to our vocabulary? Then we will output the word. We'll see that in the next section, in the next video, we will actually apply that. But for now, let's just continue. Then let's do our feed forward. So our forward is going to be, our forward pass is going to be the bed size, sequence length, token embeddings, positional embeddings. We first add the two token embeddings plus positional embeddings. We apply our dropout, and then we apply the transformer blocks, all 12 of them, or whatever, how many you want to play around with. And then we then apply the final normalization to that output, and we just output logits. So those logits are the ones that we are going to use then to to look up into our dictionary. So now here we apply it, we apply it to Let's say we apply to the batch that we had. We applied to the input batch that we had. So this is the batch that we had. It had these 4 tokens and 2 inputs. Remember from a couple of videos ago. And that's what we have there. Now let's print out what gets sent back out. These are the logits that then get sent back out for the first block, and this is for the second block, and therefore each token. So for this first token, we will have these are the logits, these then the logits, these then the logits for the third and the fourth. So they're saying when we then instead of looking at logits, if we want to behave them as probability, or we calculate the maximum one, we'll see. Okay, let's see in the next video when we're actually generating tokens. But for now, that's just the output of our model. If you want to see how many parameters, you can just calculate use dot parameters. It's a function in Torch. Just use that, and then we'll see 163 parameters. So here we say why 163 and not 124 million? Because we now have we were saying it's a GPT-2 small model, which is 124 parameters. It's because they did in their paper, they did something called weight tying. So they tied some weights, as you can see here, by setting the out head weight equal to the token embedding weight. So they tied some weights. We'll discuss it in, I think, in maybe 2 chapters to come. We discuss weight tying. So which means you don't there's some weights that you tie to other weights, and you don't train all of them. And when you do the calculation, so let's see, the token embedding layer, it's going to be model dot token embedding weight, the shape. This is the shape here, and then the output. So yeah, we're just looking at the shape, right? If we remove the out head parameters, because they've been weight tied, if we remove them, so total parameters, and we remove the output head parameters because we do not want to train them or anything, we're just tying the weights, we'll get the 124 million. So that's what they did. They just weight tied. We'll discuss weight tying in an upcoming chapter. So now imagine if each parameter was being stored as a 32 float digit, it's going to be 4 bytes per parameter. So multiplying 124 times 4 bytes will actually get that this model is 621 0.83 megabytes, and that is the smallest model. Imagine now when you start doing the bigger models. Imagine when we had 175 billion parameter model, they become quite heavy models. That's why they're so large. That's why they're called large models, because they're large, and the memory and computational requirements for them, it's quite chunky. It's quite chunky. As you can see here, our GPT-2 small model, which is the 124, it uses 768 as the dimensions. Therefore, embeddings, it has 12 layers, which have 12 layers with 12 heads. The medium one, 124 dimensions, 1024 dimensions, with 24 layers and 16 attention heads. So, which means that attention head in that masked multi-head attention, it will have 16. But the transformer block, it is repeated 24 times. It is repeated 24 times. And then for the extra large one, it has 25 heads in the multi-head attention. 25 heads. And that transformer block, including its layer normalization, the dropouts, and all of that, they are repeated 48 times. So we have 48 times, and then the embedding dimension is 1600. So cool. Now that we have our GPT model ready, let's generate some text in the next video. Now we are finally applying our GPT model.